Hey everyone, welcome back to my tutoring channel, where I will be making tutoring videos to help with STEM subjects, which in this case is mostly math. Today we'll be covering the Intermediate Value Theorem, or the IVT, which is a topic that is in both Calculus AB and Calculus BC. So what is the IVT? To start off with, we'll take any function, which we'll call f of x, and any interval, which will say starts at A and ends at B. And keep in mind, these are rectangular brackets, so it includes both A and B as endpoints. So if f of x is continuous on this interval A to B, there is guaranteed to be a value for C such that C is in between A and B, and f of C is in between f of A and f of B. And this implies that f of b is greater than f of a, but in reality it works the other way around as well. So as long as f of c is in between f of b and f of a, regardless of which one of these two are greater, and c is in between a and b, the IVT works because it guarantees both of these statements. But it has to be continuous on this interval. And so how would you check if a function is continuous on this interval? You can't exactly see the left-hand side limit, the right-hand side limit, and the actual point value at that point for every single value in an interval. Sure, it might work for one of these, but doing this for 1, 1.1, 1.2, and so on would just become very redundant and unnecessary. So what would you do? You check for discontinuities, and this means all types of discontinuities. It doesn't matter if it's a removable one in this case. There are some types of functions that you will not need to check because you know they will always be continuous, like polynomials, sine and cosine, log, exponential, and a few others. And I forgot to mention arc, tangent, or sine, cosine, tangent, inverse, because these are all continuous on their domain. So you have to check for any discontinuities these polynomials have on their domain. And for any other type of function, this could mean that this could be something like the denominator being equal to 0. So say you have this function 1 over x times x minus 2. It doesn't take very advanced mathematics to figure out that your discontinuities would be at x equals 0 and x equals 2, because if you set the denominator equal to 0, and if you set the denominator equal to 0, then you get x equals x times x plus 2 equals 0, and using the 0 rule, either one of these has to be equal to 0. And you can do something like that for just about any other function. And this type of method mostly works with rational. But even if it's a removable discontinuity, you still have to take it into account, because a discontinuity is a discontinuity. And say, for example, you have something like this, you can't exactly work with this point when dealing with the IVT. And so now once you have the discontinuities, check if those discontinuities are within your interval. So say you're looking at the interval from 0 to 4, and you have a discontinuity at x equals 3. Since 3 is between 0 and 4, that means there is a discontinuity in this interval. And since there's a discontinuity in this interval, the IVT doesn't apply, so you can just end right there. So that means if there is doesn't, IVT doesn't apply if there is. If there isn't, it works. And I apologize if this IVT looks like NT. So I will correct that right there. And so now that you have your discontinuities and all of that done, that's your IVT and it's guaranteed. But say for example, if you're trying to check if the IVT guarantees a specific value, you'd also need the additional step 3. Check if specific value for f of c is within range from f of a to f of b. Say, for example, I may have explained this a bit confused. I may have sounded confusing when explaining this, but I'll give you an example to make it a bit easier to understand. Say, for example, you're trying to see if the value 11 is in a certain range. So that means f of c is equal to 11. And you're going from the interval 2 to 9. And so f of 2 could be 3, and f of 9 could be 13. Since f of c is in between 3 and 13, so 11 is greater than 3 but less than 13, then you know there is a value for c such that c is between 2 and 9. Because one of the above inequalities turned out to be true, the other one will be true. So we checked for this one. If this is true, that's true. So to actually put the IVT into action, let's start an actual question. Take the function, and let's switch to black over here. Take the function f of x equals to 5x minus 3 over x squared minus 4 times 2x plus 1. Let a equal 1 and b equal 4. Does the IVT guarantee a value for f of c equals 0? Wait, does a IVT guarantee a value for a value 0 in this interval? So let's start by finding out where exactly this function has discontinuities. So for that, you would set the denominator equal to 0. So you have x squared minus 4 times 2x plus 1 equal to 0. And if you remember difference of two squares from any previous algebra lessons, this becomes x minus 2 and x plus 2 times 2x plus 1, which carries over from before. And if you use the zero rule, if any one of these factors are equal to 0, that means the entire thing will be equal to 0. So set each individual factor equal to 0 and solve for x. And those are all three of your solutions, which are in this case our discontinuities. So we have discontinuities at 2, -2, and -1/2. Now we have to check if any of these are in the range 1 to 4. -1/2 is not between 1 and 4. -2 is not between 1 and 4. But 2 is between 1 and 4. So we have a discontinuity in this range. So f of x is not continuous on 1 to 4. So the IVT does not apply. Thank you so much for your time, and stay tuned for the next video.